Good morning, students. Here I am going to deliver the lecture for Civil 2 again. Students, we have finished with the syllabus, and here are the lectures which we have already discussed with you, but they are just I am delivering these lectures again on these topics just for your revision purpose. Okay, so I have taken the topic once again, the two-dimensional wave equation, the derivation of two-dimensional wave equation. Okay, so if you feel any kind of doubt during this whole revision process, whole lecture, please contact me. Okay, so let us start with the topic two-dimensional wave equation. Since we know that the general two-dimensional wave equation is given by curly 2v over curly t square is equal to c square curly 2v over curly x square plus curly 2v over curly y square, where c is the constant. Now I will solve this first equation, which I have denoted the general wave equation by number 1 equation, by the method of separation of variables. I will put v is equals to x, y, t, where capital X is a function of small x only, capital Y is a function of small y only, and capital T is a function of small t only. Now the factors which I have required in equation number 1, I'll calculate those factors from here and put it into first equation. Okay, so I will firstly evaluate curly v over curly x, then curly 2v over curly x square. So curly 2v over curly x square comes to be x double dash yt, because whenever we are partially differentiating with respect to x, I will take y and t as constant. Then I will evaluate curly 2v over curly y square, which is given by xy double dash t, and curly 2v over curly t square is given by xyt double dash. Okay, now I will put all these values in equation number 1, so I am getting this one. Now according to the method of separation of variables, I will firstly separate the variables. So that's why I am dividing with the factor x, y, t, so that the variables can be separated. Okay, so what I have done, I have divided the both sides with x, y, t. So I am getting t double dash over t is equal to c square x double dash over x plus y double dash over y. So as x, y, t, they are the independent functions. They are independent functions of x, y and t respectively. So that's why this equation will reduce to some constant. So let us suppose that x double dash over x is equal to minus lambda square, y double dash over y is equal to minus mu square, and 1 upon c square t double dash over t is equal to minus lambda square minus mu square. Now students, why I have taken the value as minus lambda square and minus mu square? Because as in the lectures, the derivation for the wave in one dimensional, we have discussed that, or we concluded that the solution always come out when the constant is equal to minus b square, where b is positive. That is, when the constant we take it is negative. So that's why I have taken x double dash over x is equal to minus lambda square, y double dash over y is minus mu square, and 1 upon c square t double dash over t is will be equal to consequently minus lambda square minus mu square. So if I simplify these three equations, I am getting like this: x double dash plus lambda square x is 0, y double dash plus mu square y is 0, and t double dash plus c square into lambda square plus mu square into t is 0. Now I will solve these equations. For that, I am just reducing these equations into the form of the d. So to solve this equation, I will firstly reduce it is into the form of d. So the equation reduces to d square plus lambda square into x, d dash square plus mu square y is 0, d square plus c square lambda square plus mu square t is equal to 0. So I have just used the three types of d over here, capital D, d dash and small d, just to distinguish this differential operator. Here capital D stands for the partial differential operator with respect to x, d dash is the partial differential operator with respect to y, and small d stands for the total derivative with respect to t. As these three equations, they are homogeneous ordinary differential equations of order 2. So if it is homogeneous, because the right hand side is 0, so it contains only the complementary function, not the particular integral. Now to find the complementary function, I will firstly write its auxiliary equation. Now auxiliary equation is just written by replacing d dash and small d by m. So equations are m square plus lambda square is 0, m square plus mu square is 0, m square plus c square lambda square plus mu square is 0. So as these three equations, they are quadratic in M, so they will provide us the values of M in two numbers. Okay, the two values we'll get the from here. So from here we are getting m is equal to plus minus lambda I, here m is minus mu I, and here m is equal to plus minus c under root lambda square plus mu square iota. Okay, so the roots are imaginary, so its complementary function is given by c1 cos lambda x plus c2 sin lambda x, c3 cos mu y plus c4 sin mu y, and t is c5 cos c lambda square plus mu square under root t plus c6 c7 sin c under root lambda square plus mu square into t. So the required solution is given by multiplying these three factors, that is x by t. So let us denote this equation by equation number 2. Now I am going to use the boundary conditions as v0 by t, vl by t, vx0t, vxkt as 0, and v0 by t is equal to 0. First of all, I am going to use this condition. Basically, in first condition, I am taking x0, then y0, then x is L and y is equal to k. So these are the four boundary conditions. So when v0 by t is 0, means when x is 0, the second equation reduces to cos 0 is 1, sin 0 is 0. So I left with v is equal to c1, you can see c3 cos mu y plus c4 sin mu y, c6 cos c under root lambda square plus mu square into t, c7 c under root lambda square plus mu square into t is 0. So the product of these three factors is 0, but these two factors, this factor, this one, and this factor, they cannot be 0 because for the non-zero solution. So we are only having c1 is equal to 0. The next condition that I am using is vl by t is 0 by putting x is equal to L. So if I am putting x is equal to L in the second equation, it becomes c1 cos lambda L plus c2 sin lambda L, and rest of the factor will remain same. So c1 is 0, so I am getting only with c2 sin lambda L and the rest of the two factors. Again, the product of these three factors is non-zero, so these two factors cannot be non-zero for the non-zero solution, so I only left with c2 sin lambda is 0. Again, the product of these two function is 0, one of them should be 0, c2 cannot be 0 because c1 is already 0, so c2 cannot be 0 for the non-zero solution. So I only left with sin lambda L is 0. So if sin lambda L is 0, lambda L is equal to n pi, where n is an integer. So the solution becomes c2 is lambda L is n pi, so lambda is equal to n pi over lambda. The next condition that I am going to use is vx0t is 0, that is by putting y is equal to 0. So the equation 2 reduces to, when I put y is equal to 0 in t, I will get cos 0 is 1, c3 plus c4, c4 will be 0, c4 into 0, I will be left with this factor. Okay. Again, for the non-zero factor, c3 should be 0. The next condition that I am using is vxkt is equal to 0. So if vxkt is 0, again by putting y is equal to k, I am getting this one. Again, for the non-zero solution, same students, what I am getting, it is equal to sin mu k is equal to 0. So if your mu k is 0, then mu k is equal to m pi, where m is an integer. So mu is m pi over k. So therefore the solution 2 reduces to, we have used the four conditions by putting x is 0, by putting x is n, by putting y is 0, and then y is equals to k. I am getting as v is equal to c2 c4 sin n pi x over L, sin m pi y over k, c6 cos pt plus c7 sin pt. Now question here arises, what is p? P I am taking as c under root lambda square plus mu square. Students, we have recently calculated the values of lambda and mu over here. So I am putting the values of lambda and L. Lambda is n pi over L and mu is m pi over k. So lambda square becomes m square pi square over L square plus m square pi square over k square. I will take pi square as common. When it comes out from the under root sign, it will become c pi under root n square over L square plus m square over k square. So now in my next step, what I am going to do, in this solution, this c2 c4 will be multiplied inside. That will become c2 c4 c6 cos pt, and this will become c2 c4 c7 sin pt, and they will be further replaced by some another constant. You can see from here what I am doing over here, it is v sin n pi x over L sin m pi y over k into e n m cos pt plus f n m sin pt. Okay, what is e n m? It is c2 c4 c6, and f n m is c2 c4 c7. So the general solution is given by putting the sign sigma. So the general solution is V is sigma n varies from 1 to infinity, sigma m varies from 1 to infinity, sin n pi x over L, sin m pi y over k, E n m cos pt plus f n m sin pt. Okay, take this as number 4. Now the last condition that I am going to use for the wave equation, in one dimension we have also used these conditions. So from here we have when t is 0, v is equal to f of xy, and second is curly v over curly t by putting t is equal to 0 is also 0. First of all, I am using the first condition when t is 0, v is equals to f of xy. So if I put t is equal to 0 in in fourth equation I will get cos 0 is 1, sin 0 is 0. So it will be f of xy is equal to sigma n varies from 1 to infinity, where I am putting my cursor. Please be attentive here. Sigma m varies from 1 to infinity, sin n pi x over L, sin m pi y over k into E n m, as cos 0 will be 1 and this factor will be 0 because sin 0 is 0. Now this is the Fourier series, but here there are the two summation signs, so we will call it which is double Fourier sine series. How to evaluate this constant? It is 2 by L, 2 by k, integral 0 to L, 0 to k. The function which we have written on left hand side, that is f of xy, sin n pi x over L, sin m pi y over k, dx dy. So E n m is equal to 2 into 2 is 4, 4 upon L k, integral 0 to L, 0 to k, f of xy, sin n pi x over L, sin m pi y over k into dx dy. Take this as number 5. Okay. So the last condition, I am going to use curly v over curly t. Where is our equation? See equation number 4. Now I am going to partially differentiate this equation with respect to t, so that I can use this condition where I am putting the cursor, students, curly v over curly t when t is equal to 0. Okay. So if I partially differentiate it with respect to t, x and y, they will be considered as constant. So it will be sigma n varies from 1 to infinity, sigma m varies from 1 to infinity, sin n pi x over L, sin m pi y over k. So here it will be E n m. Differentiation of cos pt will be minus sin pt multiply p, plus f n m sin pt derivative is cos pt multiply p. After that, what I am doing? I am putting t is equal to 0. So sin 0 is 0, cos 0 is 1. So what I will be get, curly v over curly t when t is 0 is sigma m varies from 1 to infinity, sigma m varies from 1 to infinity, sin n pi x over L, sin m pi y over k into this factor will be 0. Here it will be p f n m, cos 0 is 1. So this is 0 is equal to, as this condition is given to you 0, this factor is 0, sigma n varies from 1 to infinity, m varies from 1 to infinity, p into f n m sin n pi x over L, sin m pi y over k. Now how to evaluate this constant p into f n m, or you can say this p is constant, this can come out from the sign of these summations. So this is your double Fourier sine series. So f n m is given by 2 by L, 2 by k, 0 to L, 0 to k. The factor on the left hand side is 0. It is 0 into sin n pi x over L, sin m pi y over k, dx dy. Okay, so f n m is 0. So students, the final solution is given by, you can see f n m is coming to be 0. Okay, keep remember this result also. So you can say, students, the things which you have to keep remember, the solution is given by equation number 4 for the two-dimensional wave equation. That is sigma n varies from 1 to infinity, sigma m varies from 1 to infinity, sin n pi x over L, sin m pi y over k, E n m cos pt plus f n m sin pt, where f n m is always coming to you 0. And what is E n m? E n m is given by this one, this formula, by equation number 5. These things I have mentioned at the last. The solution is given by sigma n varies from 1 to infinity, sigma m varies from 1 to infinity, E n m sin n pi x over L, sin m pi y over k, cos pt, as f n m is 0. And E n m is given by equation number 5, which I have written above. You can see, students, from here. Okay. And lastly, you can say p is equal to c by under root Ln square over L square plus m square over k square. Okay, students, so this completes the derivation of the two-dimensional wave equation. Okay, so this is very important from examination point of view. I have just make it solution by using the method of separation of variable, and it's very quite easy, and it is very much important from the examination point of view. So one-dimensional wave equation is important, as well as two-dimensional wave equation is also important. So throughout this whole lecture, whole derivation, if you feel any kind of doubt, this is just a revision lecture for you people. Okay, so that the syllabus has been finished, so don't wasting any kind of time. We are just making you people to revise the things which we have discussed already. Okay, so still students, if you feel any kind of doubt in any content of this lecture, please ask your query through WhatsApp me by using call me, or you can mail me also. Okay, thank you so much.